Section 8.5, similar objects, scale models, and scale diagrams. So how do the dimensions of each small cube relate to the overall dimensions of the Rubik's Cube? Well, it looks like each of these cubes, since the whole side is of the big cube is 3 by 3 by 3, and each little cube is 1 by 1 by 1, each cube is 1/3. The length, width, and height of each small cube is 1/3 of the length, width, and height of the Rubik's Cube. Okay? So here we have Samir. He's an engineer for an electronics company. His company currently sells a popular mini MP3. Looks a lot like an iPod. It comes packaged with a box with these dimensions. His engineers has designed a larger version of the MP3 player. Improved features, greater storage, and a new box must be created. So how can we create a new box that is similar? So what we're going to do first is we're going to make a net. And a net is taking a 3D object and putting it into shapes. And it's kind of like when you were in grade 1 or 2 and you had to make a cube and you had all the pieces, you had to fold along these lines and get them, glue them together, and it never quite turned out right. But that's what a net is, okay? So you can see that we have one side here that's going to be 10 by 6. And there's actually going to be two identical sides that are 10 by 6. So here I have my 10 by 6 and a 10 by 6. Okay. Then I have sides that are going to be 6 by 4. I'm going to have two of those. 6 by 4. Okay. Oh, it actually looks like, and then I'm going to have some 10 by 4s boxes as well. 10 by 4s. Okay, so that's my net. Question B. Choose a reasonable scale factor that you could apply to the net in order to create a larger box. Okay, so what would be a good scale factor? So let's say of 1.5. I'm going to make it 1.5 times bigger. So now I'm going to draw my new net. So instead of this side being 6, 6 times 1.5 is 9. 4 times 1.5 is 6. And 10 times 1.4 is 15. So I've taken every single dimension and made it bigger. Okay? How are the dimensions of the box related? And are your boxes similar? Explain. So the way they are related is they each have a scale factor of 1.5 of the original box. They are similar because their dimensions are related by the same scale factor. In other words, they have proportional dimensions. Each dimension of the larger box is 1.5 bigger than the original. So we've taken every single dimension and blown it up. Are the lengths of diagonals proportional? Yep, everything is that same scale factor. So we didn't compare, but if we claim that other boxes can be similar provided they have the same shapes, do you agree or disagree? Yes, if any two objects have proportional dimensions, they can be similar. Is it possible for our irregular 3D objects to be similar? Yep, as long as all corresponding dimensions are proportional. Okay, so determining actual dimensions from a scale model. So Esmeralda bought this toy tractor to give to her brother. The dimensions are given here. The scale ratio is 1 to 16. She knows her brother will want to know the size of the real tractor. He's one of those little kids that likes to know things. So how can she determine? So if this is 12.7 centimeters high on the scale, we would times it by 16 to find how big it is on the real tractor. If this was 9.5, then we times it by 16 on the real tractor. The toy was 19 centimeters, we times by 16. And that's all she's going to do here. She's going to multiply each dimension by 16 to find out how big it is. Okay? And then what she did is she converted to meters instead of having 300 centimeters. Okay? Unless they ask you to do that, you don't have to if you don't want to. Okay? So just to summarize this, I'm going to just summarize this part. The scale factor is equal to the scale model divided by the object. So just like we were doing before. If it's between 0 and 1, it's a reduction. If it's greater than 1, it's an enlargement. So not much new here.